This is the main damage area. So this shortage between positive and negative terminals, it caused to damage the fuse and other things. This PCB area is damaged. Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. I have this Delta Electronics power supply. We will connect it to series lamp to apply power, and we will check the fault condition. Then we will troubleshoot it. If you don't have good experience in electronics, never try to repair, because we are dealing with live voltage. Always take care for the safety. No indication on the lamp. Check AC voltage. 236 volt. No indication on LED. Check DC voltage. No DC voltage. No DC voltage. We can see there is a capacitor failure on this pad. That means this capacitor is damaged. This capacitor is heavily heat up, so it caused to make a print on this rubber mat. It is first visible damage on this board. Sometimes some indications are very prominent that give us a clear fault location by a visual inspection. In this area we can see damage sign. That is this area. This point and this point, this point. In first step, check voltage on this capacitor. If there are voltage, discharge it. So it is safe, there are no voltage. We can see this driver is also dead. This PCB area is damaged. This MOSFET gate drive components are looking good. These MOSFET gate drive components are also looking good. Other driver is also died. First I will clean it using isopropyl alcohol. If we see this capacitor, it was very close to blast. Always take care for the safety. Its insulation is melted. Let's check its failure. Yes, we can see its heat up place in this area. We can see these are the heat signs. we can see in this area its insulator is leaked. Yes, this is the main damage area. So this was the reason of failure of this capacitor. So this shortage between positive and negative terminals, it caused to damage the fuse and other things. Let's trace. Just for test purpose, I will take capacitor from other power supply and then I will install the original value capacitor. (240 microfarad). The printed value 270 microfarad. Its value is also low, but we will use because we are using for test purpose. Now I will check fuse continuity. Fuse open circuit. Just for test purpose, I will use 1 ampere bus fuse wire. It is best way to use low value fuse while repairing if there is something wrong. So this fuse will protect from more damaging. Now we will check input resistance. Input resistance of this circuit is 1.3 mega ohms. That's good. Positive terminal of the bridge rectifier, black lead. One input terminal, one diode. Second input terminal, second diode. Move black lead to negative terminal, one diode. Second diode. This is wrong. It must be open here. Red lead at negative terminal. This indication okay. This indication okay. Red lead at positive terminal. This reading is wrong. Now check positive terminal and negative terminal. There is short circuit between bridge rectifier positive and negative terminals. So this is wrong reading. Check this diode. This rectifier, it is good. Now check this rectifier. This rectifier is good. Check this power MOSFET. It is short circuit. Now if this MOSFET is damaged, then we need to check this line. It is also heat up. That means this MOSFET short circuit is caused to damage this line. This area is heat up, and there are very high chances for damaging this PFC controller. N60C3 Infineon MOSFET, short circuit, drain to source, source to gate, drain to gate. All three pins are short circuited. Sparking caused to overheat this diode. 0.295. In diode mode, place black lead at positive terminal, red lead at negative terminal, one diode. Reverse the leads. Open circuit, it's good indication. Now we will install this capacitor. When we are repairing any PFC based power supply, in the first step, we need to remove short circuit. If there is any short circuit, remove that short circuit. If short circuit is finished, we will receive DC voltage based on AC voltage. AC voltage multiply with 1.414, that DC voltage must present at this capacitor. Then there is no short circuit. If any stage is not working, the first step, we need to maintain DC voltage here. If there is short circuit in any stage, in PFC section, in power stage, or in standby section, we will not receive voltage at this capacitor. If bridge rectifier is bad, if there is any short circuit here in input line, it will not allow to build voltage. Then we need to turn on this section. When it will turn on, it will sense the voltage and it will turn on this bypass relay. Here is soft starter circuit, that is surge protection for this capacitor, that this capacitor will take huge amount of current while initial charging. This thermistor will protect that current, it will limit that current. When capacitor will obtain some good voltage, at that time this relay will turn on. If this section is working good, then we can continue to next sections. Then we can monitor output and we can monitor this section. We can repair PFC section. Or first we will verify this PFC section, then we can focus on this section. Let's check it now. That's good. The relay is giving tick sound, click sound. That means the relay turned on. Check DC voltage on this capacitor. 327 volt. That's good. Now LED is turned on. That means this section is in good working condition. (23.7 volts). Yes, now the voltage are maintained. That means just we need to repair PFC section. Now we will use this MOSFET. Diodes, open circuit, red lead test to gate, now channel turned on, reverse the leads, now touch black lead to gate, now one diode, reverse the leads. The MOSFET is good. इस पार्ट नंबर है BYC 8X600, 8 ampere 600 volt. Because its PCB second side is damaged, there is no eyelet, so I will solder from this side. Because this track is damaged from this point, so we need to install reinforcement to this track. So in this condition, this track, this portion become weak. If you will not install reinforcement, it will damage quickly because it will not support to full current. Now it's good. Now we need to check these gate drive components. Diode, we need to remove this diode because there is parallel resistance. This diode is good. 3.3 ohm resistor good. 30 ohm resistor good. 10k resistor good. Now I will install this diode in PCB. Now let's apply power. If it starts normally, then it's good. Otherwise we need to replace PFC controller. We can see the lamp turned on, but PFC circuit not started. DC voltage 327 volt. That means its PFC controller is damaged because we installed MOSFET. Gate drive components are good, so it must take start. Discharge the capacitor. Now it's safe. First we will check continuity between this gate drive pin and pin number 8 of this NCP1654. This continuity is good. Then this diode, good. Now we will measure VCC voltage of this IC very carefully. Ground and pin number 7. Yes, we have VCC voltage. So this PFC controller is not working. Yes, the problem PFC not starting. It is flashing now. That means this PFC controller IC is started working, but there is something wrong. यहाँ पर ये इसकी इनपुट वोल्टेज सेंस लाइन है. This is input voltage sense line. This diode is good. From positive terminal to this point, this line is good. Yes, this resistor, positive terminal is reaching at this point, but it is not reaching to this point. Due to overheat condition, this resistor is open. If we check this resistor, this resistor good, this resistor open, this resistor open, this resistor 909K good, 909K good, this resistor open, and this resistor open. This is due to this capacitor. Yes, 900K, 909K, 909K. Now I will use these two resistors. this line is good. From here to here 1 mega, 909K, 2.5. From here 2.5, that's 2 mega ohms. We are testing two resistors in series, and this end will be connected at pin number 6. That's good. So this voltage feedback, this was missing. Okay, now let's test it. Yes, that's nice. Now we can see when PFC circuit started working, this lamp flashes continuously with high repetitions. Then this lamp returned back to normal. That means the PFC circuit started boosting voltage, and now we will check voltage on this capacitor. 391.2 volt. Now PFC circuit started working, and if we check voltage now, 24.9. excellent. So now this power supply is repaired successfully. Now we can see, due to overheating of this capacitor, these resistors damaged. Sparking here caused to damage this power MOSFET. Power MOSFET damaged this PFC controller. We replaced PFC controller, then the feedback was missing. When feedback was missing, it was not maintaining the voltage. When we replaced these resistors, and now PFC controller is working normally. We repaired this track. Now I need capacitor, power MOSFET, fuse. That's nice. DC voltage 394.6. The output is good. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.